Hi everyone, my name is Eli Singer. I'm the CEO of Jethro Data, and we'll talk about BI on Hadoop and how to make it work. Many of our customers are in the process of offloading their BI applications from legacy DW to Hadoop. And what they try is what they worked for them for many years. You just point your BI tools directly at Hadoop. And it doesn't really matter what kind of SQL Hadoop tool you would be using. Spark SQL, Impala, Hive Drill, and so on. The bottom line is that those tools are too slow. They full scan every query that you run, and in result is too slow. And slow BI is no BI. Now, what do you do when your BI application is just too slow when running on your Hadoop platform? What people end up doing is what we call data engineering acrobatics. They end up taking their data sets and they pre-aggregate, pre-calculate, they denormalize, build partitions, cubes, and so on, trying to speed up BI access to their Hadoop data. Now, very quickly, this becomes hard to maintain. You cannot keep up every time a user changes the dashboard to go and build an aggregation for them. So the next thing we see people are doing is push this problem all the way to the end users. From self-service BI, we end up with self-service performance. We ask our end users to create their extracts or build their own cubes to speed up their queries. And of course, this is a tremendous waste of their time. So what's happening here is that we are trying to solve the performance problem that is part of the data platform in the wrong place. It makes absolutely no sense to have our IT waste their resources building all of those aggregations, or to ask the end users to build their own extracts. If the BI platform requires a data platform that is performant, the fix has to be applied to the data platform. So this is what Jethro is all about. We are about speeding up BI on Hadoop. Jethro sits as a transparent layer between your BI application and your Hadoop platform. The way we speed up access is by taking the Hadoop data sets and add indexes. We index every column. We add cube aggregations based on queries sent by the application and auto-caching. All of it is self-driving. No data engineering is needed, and the application itself adjusts to data changes and application changes. The key to Jethro is the combination of cubes and indexes. If you think of BI queries, they range from being very aggregated. Some sales grew by state. I want to see the total sales of all the rows that I have in the data set. This type of query, very aggregated, benefits from cube. If I create a cube aggregation for this query, it will take no time. The other extreme, we have very granular queries. Something like, show me all the transactions by user 123. In this case, aggregations are not going to work. The only thing that would work is indexes. And what's unique about Jetro's solution is that we combine both aggregation and indexes. We use an optimizer to choose for each query which way to go. Would this query be benefited from indexes or from aggregations? If the query will benefit from aggregations, we will create a cube aggregation for it. Now, these two strategies are very complementary, which means there's very little overlap between them. The types of queries that would work great for indexes will be terrible with cubes. Think of it. If you want to get all the rows, all transactions for a specific customer, a cube with a customer ID will be gigantic, way too big to be effective. That's where indexes work well. And if you want to run an aggregation that shows you all sales by all states without any filtering, indexes will be useless. So those two really complement each other, very little overlap, and you need to have both if you want to have a full support for BI queries. Okay? Now, what is the process? How does this thing all come together? The main idea here is that all the heavy lifting, the queue building, the indexes, all done in the background. Okay? So if this is your environment, we have data in Hive table, HDFS table, could be SQL sources, doesn't really matter. What Jethro does is read that data set, and only BI data sets, not all of your data in Hadoop, and creates a highly optimized version of this data set back in Hadoop. Highly optimized means it's indexed and it's aggregated. Now at runtime, we get the queries from the BI tools, and we have much less work to do. The data is already pre-indexed and aggregated. All the heavy lifting was done. So at runtime, the amount of work is much smaller. and therefore we can respond much faster at much greater scale. Okay? Give you some more details. We can incorporate data into Jethro. Sure. The question is where the data lives. The data never leaves Hadoop. Everything Jethro does is within Hadoop. The cube building is within Hadoop. The indexes are within Hadoop. The query engine is within Hadoop. Sorry? If you have your data in Impala, same thing as you see as Hive. We would just read it from Impala, create an index version of the data set, store it back in Hadoop. And then when we get queries from BI tools, we will use the indexed version of the data set. Okay? So the data can come from any place, from Hive or Impala, from CSV files, SQL database, everything. We index every column because when you give your users self-service BI tools like Tableau, you want them to be able to filter by any column. You don't want to limit them. So we index every column. We build cubes based on the actual user queries. We use Hadoop as our storage. And Jethro takes about a third, 30% more size of the original raw data. So if your data set was about a terabyte, Jethro will take about 350 gigabytes in Hadoop. Net result, we can provide the performance. Every query you have in your BI tool will be accelerated. We can provide the scale, thousands of concurrent users, billions of rows, and we do it without the extra work, without the data engineering, and without changing your BI applications. Lastly, if you want to put together Jethro in the marketplace and how we compare to other tools, the first option you have is just point your BI tools at Hadoop, any SQL server on Hadoop. And the challenge with that approach is, of course, full scan. Those tools will have to full scan every filter of every query, of every dashboard, of every user, every time. The only exception is if you filter by partition key. Other than that, you full scan the data. Then we have tools that provide cubes on Hadoop. They're good for some queries that you can add to a cube. They cannot do the queries that are too granular or just simply did not fit within a cube. And then there is Jethro's approach, which combines both the indexes and the cubes together. And the difference here is that we can accelerate all queries, and it's fully automated. You don't have to define your cubes, you don't have to define your indexes. It's fully automated. Very easy to deploy. Jethro can be installed in minutes. You can download it from our site. You can index the existing data sets in hours. You can apply Jethro gradually. It's not an all or nothing. You choose one application, you take its data set, and you accelerate it. And then you can scale out Jethro servers to support any level of concurrency, any number of users that you have. So with that, I wanted to thank you. And if you have any other questions, I'll be happy to answer.
Looks good.
Excellent.